Hello, everyone, and welcome to the second lecture on sets. After defining a set and after we talked about two sets that are equivalents and two sets that are equal, and we said we are going to use n to be the infinite set that has all the natural numbers. Yeah, if you skip that lecture, please go ahead and watch that the lecture on 2.1, section 2.1, and come back and to watch this one here. And please, like I said in the introduction video, please take notes and pause it and go back and forth till you understand it before you go to the homework. Well, today, or this time, we'll be talking about subsets and proper subsets. Before I do that, let's see if I take a set A of elements, let's say 1, 2, 3, A. So n of A, the cardinality of A is 4 because A has 4 elements. And in the previous, previous lecture, we talked about two symbols, an element of and not an element of. So what does this mean? I mean, if you have an element of a set A, use this symbol. If not, use this one here instead. Today, we'll be talking about brand new symbols, a subset of, a proper subset. And of course, if we put the slash, it will say not a subset of, not a proper subset. You will see what I'm talking about in the next slides. So again, let's talk about subsets. So when you finish this lecture, you should be able to recognize subsets and proper subsets, and you should be able to count or to determine the number of subsets and the number of proper subsets when you are given a set. So let A be a set. So a subset of A is a set, and the symbol is this one here, right? So if A is a subset of B, that's how you, so this sentence, set A is a subset of B, can be symbolized using this notation here. Again, why are we doing this? Why are we doing this? Just to save some ink and not to write too much. So when can we say that? We say that when every element of set A is also an element of set B. When every element of set A happens to be an element of set B, we say that A is a subset of B. Well, and if not, then we say it's not a subset of the element. It's not a subset of the set. Here's an example. So if you take this example here, so A, let A be the set of 3 elements, the cardinality 3, boat, train, and plane. And he said B has boat, train, plane, and automobile. So is A a subset of B? Yes, because every element in A happens to be an element of B. So therefore, we have A is a subset of B, just like you see here in this one here. And of course, B is not a subset of A, because if you see automobile is in B, it's an element of B, but not in A. Let me ask you this question. Can I say A is a subset of itself? The answer is always true, because every element of A is an element of A. That's, of course, obvious. So a set is always a subset of itself. Even though it's a boring example, but just in case you encounter this in an exercise, then you say it's true. Now, what's the difference between a set and a proper subset? Well, let me give you this set here, let's say A, or let me call it, I don't know, let me call it something else. Let me call it C, set C. If I say set C is 1 and 2, is set of cardinality 2. If I take this set M, which is 1, 2, right, which is the same thing, these are two equal sets. Can I say M is a subset of C? The answer is yes. But M, since M is equal to C, I still can say it's a subset, but it is not a proper subset. So what is a proper subset? For example, like K, if I take K, I didn't take every element of C. So K is a proper subset of C. So this is the symbol for proper subset. You don't put an equal sign just like this one here, right? You put this is a proper subset. So what makes a subset a proper subset? when it is a subset, but you are not taking every element of the original set. That's what it is. So if we if we read this definition all together, give me 1 second here, we are going to say set A is a proper subset of B, and the symbol is this one here, right? This is just like a curved U or something, right? So this is the symbol. This is the symbol for proper subset. If and only if all the elements of A are elements of B. First of all, it must be a subset. A proper subset is a subset, but the two sets must be not equal to each other. So in other words, set B must contain at least one element not in set A. At least one, right? That's the definition of a proper subset. Okay, here's an example. Suppose I have A is a set jazz, pop, hip hop. Hip hop is just one element. If B is classical, jazz, pop, rap, hip hop. So is A a subset of B? Yes, because every element in A is an element of B, so it is a subset. Is it a proper subset? The answer is yes, because you can see that there are elements in B that are in A. All it takes just one element. For example, classical is an element of B, but not in A. So therefore, A is a proper subset of A is a proper subset of B. Is B a proper subset of A in this example? Of course not. Remember, a proper subset has to be a subset, first of all. Well, B is not a subset of A because there are elements in B that are not in A. Okay, so yeah, since all the elements of A are contained in B, that's the first condition. And since A and B are not equal, therefore A is a proper subset of B. Again, this is how we can say, this is to say A is a proper subset of B. Dot here just to dot of this dot here, right here, this dot here, it's just a part of, paragraph. So it has no mathematical meaning. Okay, determine, here's another example. Let's determine whether a set A is a proper subset of B. Here's set A and here's set B. Is A subset of B? Yes. Is it a proper? No, because A and B are equal. So the solution, A is not, you see that slash here? To say is not a proper subset of B. Okay, now if I go back to this, let me just work with this example here. So I'll use this as an example. Well, let me create a brand new set. K equals 1, 2, 3, and 4. Can you list all the subsets of K? Well, this is a subset of K. 1, 2, 3 is a subset of K. 3, 4 is a subset of K. Actually, the empty set is a subset of K because the empty set is always a subset of any other set, including itself. Yeah, but can I list them all? More importantly, can I tell upfront without, necessarily write them all? Can I tell how many elements or how many subsets I can get out of a given set? Well, that's the next theorem. So the number of distinct subsets of a set A is 2 to the power n. And what does n mean? Is the cardinality or the cardinal of A. For example, in this set K that I gave you originally, what's the cardinality of it? How many elements it contains? 4. 1, 2, 3, 4. It has 4 elements. Now, if someone asks you how many subsets you can give out of this set K, is 2 to the power 4. 2 to the power 4 is 16. Means there are 16 subsets. And here I listed only 4 of them. 1, 2, 3, 4. But I can move on and on and on. I'll give you an example where we are going to list all the subsets. But if the question was just how many, they're not asking you to list them all. They are asking you just to tell me or to tell them how many subsets, distinct subsets. And then you say 2 to the power n, and n is the number of elements of the original set. Now, how many proper subsets? Well, remember, a proper subset is a subset. And since we have 2 to the power n subsets, then remember, we are not allowed to use the whole set because the whole set is a subset, but is not a proper subset. So that's why there are 2 to the power n minus 1 proper subsets. if I go back to this example and ask you here K, my set K, n is equal to 4, how many subsets again? We have 2 to the power 4, which is 16. How many proper subsets is 2 to the power 4 minus 1, which is 16 minus 1, which is 15. And we say that K has 15 proper subsets. And actually, the ones I listed here are 4 of those 15 proper subsets. Yeah. Go back to this. All right, well, here's an example. Suppose we have this set has these capital letters, SE or SLED. So how many subsets do we have? We have 2 to the power 4, which is 2 times 2 times 2 times 2, which is 16. And here they are. I'm going to list all the subsets. SLED, well, it's a subset. Just SLE, SLD. Well, if you swap them around, you cannot say SLD, DLS, SDL. These are the same sets. So that's why I said distinct subsets. And if you count all of them, you are going to see there are 16 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Remember, the proper subset and the set itself are, I'm sorry, the empty set, not the proper set. I missaid that. The empty set and the whole set are subsets. If you exclude the first one, then you are left with the proper subsets. Yeah. So again, the game is pretty easy and clear. If you are given a set of cardinality n, of number of elements n, there are 2 to the power n subsets, and there are 2 to the power n minus 1 proper subsets. And how can you decide whether a set is a subset of another set? You just look at the elements. If every element of, say, set A is an element set B, we say that A is a subset of set B. I hope you get the idea. It may sound a little bit complicated, but trust me, once you start doing exercises, it's not that bad. Okay, so this is 2.2. So go ahead and start your homework. And after that, you move on to 2.3. If you have any questions, you know what to do. Let me know.